Dear interstellar traveler, please close your eyes. Let your breath gently synchronize with the heartbeat of Earth. This is a scientific harbor for souls yearning for peaceful sleep. Tonight, let us spread a gentle blanket of knowledge across the vast sea of stars. The sleepy facts you are about to hear are like spakes of thought dust drifting in the cosmic depths. Did you know Jupiter continuously plays an infrasound symphony with frequencies 1,000,000 times lower than the human hearing threshold? The pulsar in the Crab Nebula flashes every 33 milliseconds, a cosmic timekeeper more precise than an emerald pocket watch. These relaxing astronomy facts will weave into the most unique calming space documentary, projecting a personalized space documentary for sleep deep within your consciousness. Why are all planets suspended in space? The Earth weighs 60 trillion tons. Why doesn't it fall down whenever night falls? We look up at the starry sky among those twinkling points of light. Like countless planets, like Earth, they, like Earth, float quietly in the vast universe. So what force steadily keeps countless planets suspended in space today? Let's have a good chat about this scientific mystery hidden in the starry sky. Let's see how the universe keeps all planets in their proper places. To solve this puzzle, we need to understand the most pervasive force in the universe, gravity. Back in school, we came across the term gravity, but its wonders far exceed your imagination. Over 300 years ago, Newton discovered this fundamental law of the universe. Any objects with mass attract each other. The greater the mass and the closer the distance, the stronger this attractive force becomes. It's like the gravity between you and the person next to you. It's just that the mass is too small for us to feel its presence. But when it comes to giants like Earth and the Sun, gravity becomes the invisible rope governing the order of the universe. In the solar system, the Sun, as the largest celestial body, accounts for 99.86% of the entire solar system's mass. That's equivalent to the weight of 330,000 Earths combined. The gravity it generates is like an invisible giant hand, firmly grasping all celestial bodies within the solar system, including the 8 planets, moons, asteroids, and comets. All are pulled by this force. Our Earth is no exception. The Sun's gravity is constantly pulling Earth towards itself, like a parent holding on to a wandering child. But curiously, Earth hasn't been pulled in. Instead, it has been orbiting the Sun for 4.6 billion years. Why is that? This brings us to another key player, centrifugal force. When Earth orbits the Sun at a speed of 29.78 kilometers per second, it also generates a powerful centrifugal force. This force perfectly balances out the Sun's gravitational pull. Therefore, Earth remains in a stable orbit, neither crashing into the Sun nor escaping the solar system. Here's a particularly interesting point. Why doesn't Earth fall down? In fact, in the universe, there is no concept of up or down. Due to Earth's gravity, ripe apples fall to the ground, and people who jump up land back on the surface, all because of gravity. But in space, without fixed objects as reference points, all directions are equal. All planets are suspended in space. They don't fall in any direction, so the suspension of planets is just our intuitive feeling. In reality, they are all moving at high speeds along their own orbits. It's just that there's no familiar ground for them to fall onto, of course. There's another important reason: the vacuum environment of space on Earth. Whether running or throwing something, we are affected by air resistance. For example, a thrown ball slowly stops, and when running, you feel the wind pushing against you, but space is currently known to humanity as the closest thing to a perfect vacuum. There are almost no air molecules, so planets moving through it experience almost no resistance. Even more astonishingly, the entire solar system is racing through interstellar space, but the sun is leading all members of the solar system in a rotation around the center of the Milky Way galaxy at a staggering speed of 220 kilometers per second. This speed is simply unimaginable, but because all celestial bodies are moving in sync, it's like being on a high-speed train. You and the person next to you are relatively stationary. We completely fail to perceive this high-speed motion, and the sun itself is held by the supermassive black hole at the center of the Milky Way. Just as Earth orbits the sun, forming a nested system of motion layer upon layer, the entire universe is like a precise clock, with every part operating according to rules. Our Earth, besides orbiting the sun, also rotates on its own axis. Earth's rotation speed is for 165 meters per second, roughly half the speed of a commercial airliner. It is this rotation that gives us the alternation of day and night. Interestingly, the centrifugal force generated by Earth's rotation makes the equatorial radius 21 kilometers larger than the polar radius, as if it were slightly bulging, like a spinning top. Although this centrifugal force does little to counteract the sun's gravity, it is crucial for Earth's own stability, such as maintaining Earth's magnetic field and regulating climate, etc. Some might worry, could this balance be suddenly broken one day? For example, if Earth slows down from fatigue or gets hit by another celestial body. Actually, the stability of the universe far exceeds our imagination. The solar system has existed for 4.6 billion years, and the orbital changes of the 8 planets are extremely slow. The error in Earth's orbital period is only a few seconds per million years. To break this balance, an interstellar event would be needed, such as a massive rogue star entering the solar system. Its gravity could disrupt planetary orbits, or a shockwave from a supernova explosion sweeping through the solar system, altering the motion of celestial bodies. But the probability of such events is very low. Scientists have calculated the orbits of stars near the solar system and found that within 1.9 million years, no massive star will enter our solar system. Another possible change is waiting 5 billion years from now, when the sun becomes a red giant. At that time, the sun will expand to engulf Mercury and Venus, and might even approach Earth's orbit. But even then, the change in the sun's gravity would occur slowly. Earth wouldn't suddenly go out of control and fall. Moreover, given the pace of human civilization development, humans 5 billion years from now might have already found a solution, or perhaps even moved Earth elsewhere. Actually, from a certain perspective, Earth is always falling just towards the sun, because the sun is flying ahead and Earth is chasing behind. This chase has lasted for 4.6 billion years. Without a single miss, ancient humans had no scientific instruments and could only observe the stars with the naked eye. Yet, they still deduced the laws of celestial motion, created calendars, and guided agricultural activities. It wasn't until Newton discovered universal gravitation that humans gradually began to unravel the mysteries of the universe. Now we know that those twinkling stars are also celestial bodies like Earth. They also orbit their respective stars. Because of universal gravitation, Earth can safely float in the universe and orbit the Sun. It is precisely this stability that gives Earth an environment suitable for life, keeping surface temperature variations relatively small with a suitable rotation period so that the day-night temperature difference isn't too extreme. Another reason is that Earth's distance from the Sun is just right, not too far to freeze, nor too close to be scorched. These seemingly coincidental conditions are actually the result of the long-term evolution of the universe, and humans are the lucky outcome of this evolution. When we see the Moon orbiting Earth at night, and Earth orbiting the Sun, doesn't it make the universe seem marvelous? It doesn't let massive planets collide randomly. Instead, it uses gravity and motion to weave a safety net, allowing life to thrive on this planet. This beautiful blue planet holds mountains, rivers, lakes, seas, and all living things. It holds the entire history of human civilization. Unlike rogue planets in the universe that have nothing to rely on, it operates stably within the solar system, safely carrying the miracle of life. Now, humans can launch probes to explore the solar system and even observe galaxies billions of light years away. But the more we explore space, the more we feel the vastness of the universe and the preciousness of Earth in the known universe. No second planet like Earth with intelligent life has been found. Those seemingly suspended planets are actually in their respective orbits, guarding the order of the universe. Earth is the most special one among them because it is our only home in the universe, and such a home is unique, worthy of our lifelong protection. Why do all celestial bodies in the universe float there without falling into an abyss? For example, Earth falls towards the Sun at 30 kilometers per second, yet hasn't collided in for 0.6 billion years. Your answer might be gravity, but gravity isn't a force at all. It's just a massive glitch in the fabric of the universe, a space-time illusion in which everyone is deeply immersed. We have to blame Newton and that apple hitting his head. He gave us an overly simple, even deceptively perfect, wrong answer, making us stop questioning the true nature of gravity. Look at science today. It can measure and predict every effect of gravity with extreme precision. It can hold planets in their orbits, and it can slow down your clock. But when we place gravity at the most microscopic, quantum level, what exactly is it? We still know nothing. And this is the truly terrifying aspect of the space-time illusion we mentioned at the beginning. It genuinely affects everything, but its true face remains unknown to anyone. So this video offers no ultimate answer, because even the smartest minds on Earth haven't yet cracked this cosmic code. What we can do next is use our brains and dig deeper together, discussing and witnessing firsthand how incredible this reality we depend on truly is. First, the first weird thing about gravity is that it's unimaginably weak. It's the absolute ruler on the cosmic macro scale, yet its strength is minuscule. Put it this way, every time you stand up from a chair, every time you pick up your phone, you are easily winning a tug-of-war against the entire Earth's gravity, and your opponent is a behemoth with a mass of 59.7 trillion kilograms. That's a number with 24 zeros after it. But on the other hand, it's this seemingly feeble gravity that is strong enough to imprison the moon in its orbit. The moon's faint gravity is enough to drag entire oceans, creating tides under our feet. So a huge contradiction appears. Is gravity so weak it's negligible, or strong enough to shape entire galaxies? Among its many perplexing characteristics, it is both so insignificant, yet it is precisely the most powerful ruler that exists everywhere in this universe. To truly understand this contradiction, we must pit it against the other three fundamental forces of the universe: electromagnetic force, weak nuclear force, and strong nuclear force. You ask why gravity isn't included? It actually doesn't qualify to stand on this force arena. We'll get to that later. First up, the strong nuclear force. The strongest king in nature, its job is to forcibly bind positively charged protons and neutrons, which should repel each other, together to form atomic nuclei. Without it, there would be no complex matter structures. How much stronger is it than gravity? A number that will make your scalp tingle. 100 trillion times stronger. However, this king only operates within the extremely small confines of the atomic nucleus. Next is the weak nuclear force. It governs radioactive decay and is a key player in nuclear fission and fusion. Even though its name contains weak, it's still 1,025 times stronger than gravity. Finally, the most familiar one, electromagnetic force, the cornerstone of our modern civilization. From electricity to the internet, all stem from its magic. To feel its power, just look at the compass in your hand. It's YP times stronger than gravity. And, like gravity, it can also operate on a macroscopic scale. We'll come back to this point later. Now, back to how gravity beaten black and blue on the force arena. Remember how much weaker it is than all the other forces. Now take a deep breath and realize that it is this seemingly most fragile existence in the universe that created galaxies, shaped the solar system, and ultimately gave birth to us. It's safe to say that without gravity, the universe would be an eternal void composed of ghost-like particles. No structure, no celestial bodies, and, naturally, no life. Its secret doesn't lie in strength, but in its relentless persistence. Given enough time, the weakest persistence can drip through stone, carving nothingness into the intricate universe we see today. It all started with the tiniest particles clustering together, then using stronger gravity to attract more companions, over and over, eventually igniting stars, coalescing planets, and painting entire galaxies. This process took an unimaginably long time, but the shaping of the universe is still ongoing at this very moment. So, if you thought gravity was just an invisible pulling force, its imprint is actually already branded on every inch of the universe's skin, from stellar embryos to the outlines of black holes, to the spirals of galaxies. Despite being unbelievably weak, no one can escape its control. You might wonder, how can something so weak simultaneously govern both planets and entire galaxies? This leads to another mind-bending characteristic of gravity. Its range of influence is infinite. Just like Obi-Wan Kenobi described the Force in Star Wars, it surrounds us, penetrates us, and binds the galaxy together. Replace all living things with all objects with mass, and this is the perfect description of gravity. The concept of infinite is hard to grasp, because in reality, almost nothing is boundless, but gravity's reach theoretically extends to the end of the universe. This means every atom in your body is exerting a minuscule but real influence on some star in the Andromeda galaxy. From this perspective, gravity's fundamentality and universality are, in turn, incredibly powerful. Of course, the word infinite needs a few caveats. First, its propagation speed cannot exceed the speed of light. This means if the sun disappeared, we would only feel the change in gravity after 8 minutes second. Its strength diminishes drastically with the square of the distance. Simply put, every time you double the distance, its strength becomes only 1/4. So even though its range is infinite, in the vastness of space, gravitational effects quickly become negligible. This is why in any given location, it's always the biggest, nearest object that calls the shots. It can overpower the faint gravity of all distant celestial bodies, thus shaping independent galaxies and solar systems. So what effect does the gravity generated by your body have on the universe? Assuming you weigh 100 kilograms, the gravitational force between you and another you is only 0.001713 newtons, almost zero. This reminds us again how insignificant gravity is in most cases. However, your body and all objects with mass are experiencing another, even more bizarre effect of gravity, and this topic will officially shift our understanding of gravity from peculiar to downright eerie. We are, of course, talking about time dilation, a concept most people have heard of, but fundamentally misunderstand. You will discover that the flow of time for each of us varies due to gravity, and once you truly understand it, you might have an epiphany. The act of measuring time might be fundamentally meaningless. Gravitational time dilation. This concept sounds sci-fi, but its principle was clearly summarized long ago in Einstein's theory of relativity. General relativity tells us an incredible fact. The closer you are to the center of a gravitational source, the slower your time passes. Conversely, the farther away you are, the weaker the gravity, and the faster time flows. So, a harsh truth is, we, living on the Earth's surface, are at the bottom layer where time flows the slowest. Those farther from the Earth's center, like people living on the top floor of a high-rise or on a mountain peak, indeed experience time passing slightly faster than we do. Of course, this is a simplified understanding. The reality is much more complex. Because the Earth's surface isn't perfectly uniform, gravity has tiny variations everywhere. This means that right now, each of our personal time rulers are advancing at different rates. Specifically, how much difference? A basic formula For every kilometer increase in altitude, your clock runs about 10 nanoseconds faster per day compared to the ground. In other words, a mountain climber does age faster than a deep-sea diver. Following this logic, astronauts in orbit on the space station so far from Earth should experience time passing faster, right? On the contrary, they actually become younger because here Einstein's other theory, special relativity, comes into play. It tells us that speed also slows down time. This is indeed a bit convoluted. Just remember, general relativity proves gravity makes time pass faster at higher altitudes. Special relativity proves high-speed motion also slows down time. The International Space Station flies at an astonishing speed of 7,700 meters per second. The time-slowing effect due to its speed completely overwhelms the time-speeding effect due to its height. The result is that after astronauts complete a 6-month mission in space, they are about 0.07 seconds younger than us on the ground. Yes, this amount of time is completely negligible for us personally, but the key point is, this difference is greater than zero. Given enough time, it can accumulate into an astonishing number. A perfect example. After 4.5 billion years of accumulation, the Earth's core is a full 2.5 years younger than the Earth's crust. This effect is vividly demonstrated in a human-made object, and even directly impacts our modern life. GPS satellites. They are at an altitude of 20,000 kilometers, flying at 22,000 kilometers per hour. They are subject to both gravitational and velocity-based time distortion. After the two effects pull against each other, the final result is that the clocks on GPS satellites run about 38 microseconds faster per day than those on the ground. 38 microseconds is 1/38 of a second. It sounds negligible, but the GPS system relies on calculating the precise travel time of signals to determine position. Any tiny deviation accumulated over time could lead your navigation to direct you into the Pacific Ocean. Precisely for this reason, every GPS satellite has extremely complex algorithms built in to continuously correct this time deviation caused by gravity. Now, don't you feel something is off? We previously compared it with the other three forces, but electromagnetic force doesn't warp time. Strong and weak nuclear forces don't either. Why is gravity so special? The answer we've been hinting at all along: gravity shouldn't even be on that list of forces at all. Its way of operating is fundamentally different from all other forces. It is not a force in the universe, but a curvature of the very canvas of the universe, space-time itself. It is this distortion at the space-time level that produces the eerie phenomenon of time dilation, and it is this distortion that allows gravity to do something no other force can do: bend light, even though light has no mass. Speaking of this, our understanding of gravity will officially leap from eerie to almost magical. So, how exactly does gravity warp space-time? You've likely seen this classic demonstration. A bowling ball is placed on a stretched rubber sheet. The rubber sheet immediately sags downwards. The bowling ball represents a celestial body, and the rubber sheet represents space-time. This analogy is vivid, but it's also highly misleading, because it makes you think space-time is just a two-dimensional plane. The truth is, an object with mass doesn't just press a dent on space-time. It wraps and warps the space-time asterisk around asterisk it in all dimensions inward. It is this dimensional level distortion that makes gravity completely distinct from all other forces, making it a unique, almost magical existence. It not only warps time, but also space itself. This directly changes the path of all objects, including light. We all know light always travels in a straight line in a vacuum, but when it passes through a region of space-time warped by gravity, it has no choice but to follow this already curved straight line. Imagine a straight highway suddenly distorted by the earthquake. The winding and undulating terrain, your driving path on it, naturally becomes curved. The same goes for light, so even though light has no mass, it must submit to gravity. When you stop to truly understand the meaning of this statement, a massless thing being firmly controlled by gravity, this idea is enough to shatter our most fundamental understanding of the physical world. Want to see this space-time distortion with your own eyes? The bad news is the distortion caused by Earth's mass is so weak that we simply cannot see light bending. The good news is the depths of the universe are full of giants performing for us. And these cosmic wonders have become late-night companions for many people's thoughts. When astronomers point telescopes at distant galaxy clusters, a spectacle known as gravitational lensing occurs. We see the more distant starlight from behind the galaxy cluster, severely distorted and stretched as it passes this massive gravitational source, sometimes even forming a perfect ring. This is the famous Einstein ring. What we are seeing is the light traveling along the space-time path bent by the galaxy cluster. Reaching our eyes, however, even such a spectacular cosmic sight pales in comparison to gravity's most extreme, most terrifying manifestation, the ultimate abyss of the universe, black holes. Now you finally understand why even light cannot escape a black hole. A planet's gravity just makes the road of space-time curve. A black hole's gravity directly snaps that road. It creates an inescapable deep well where space-time curvature tends towards infinity. Anything, including light, once it falls in, is equivalent to falling out of our space-time dimension. As for what light actually experiences inside a black hole, this is a question that even the smartest minds today cannot answer. When too much gravity concentrates at a point, all our proud physical laws instantly break down. And speaking of baffling geniuses, it's time for us to move from magical into the final mystery of gravity, which we truly completely cannot understand. When we think gravity is the curvature of space-time, we have actually just touched the deepest edge. Because when we zoom our perspective from the grand cosmos down to the incredible quantum scale, a huge chasm appears in the macroscopic world. Einstein's general relativity is gone. Gravity, as a geometric property of space-time, works flawlessly, but when you try to use the same theory to describe the subatomic world, you find it completely fails. All equations break down. All predictions point to infinity. The edifice of physics has an insurmountable crack here. What's the problem? The problem is the other three fundamental forces: electromagnetic, strong, and weak nuclear forces in the quantum world. All have a messenger responsible for transmitting the force, a mediator particle, but gravity, this ripple in space-time, where is its messenger? We have found no evidence of its existence to this day. This leads to an almost crazy conclusion. To understand gravity at the quantum level, we must quantize space-time itself, break it into the smallest indivisible units. But doing so generates countless paradoxes, enough to make our entire existing physics model collapse completely. So the quantum enigma of gravity remains to this day the sword of Damocles hanging over all physicists' heads, the deepest fog in modern science. Of course, humanity never stops exploring ultimate truth, from hypothesizing a graviton particle that transmits gravity to string theory trying to unify the universe with the 11-dimensional strings, to loop quantum gravity theory, weaving space-time into a network of loops. Countless theories, brilliant minds are all trying to bridge this chasm between the macro and micro worlds. But these, for now, remain beautiful hypotheses. Some scientists, like Jonathan Oppenheimer from University College London, have proposed an even bolder idea. Perhaps we shouldn't force unification at all. He believes the next theory might be neither classical nor quantum, but a hybrid theory we've never imagined, allowing classical space-time and quantum systems to coexist and interact. This might require us to make revolutionary revisions to both the existing pillars of physics. This idea is still niche for now, but it represents a possibility. Perhaps the way we solve the mystery of gravity isn't to find one key, but to tear down the entire wall and build a brand new model of the world. So at the end of this journey, please don't feel uneasy about your confusion, because no matter how incomprehensible the reality of gravity is to you and me, it is the same for the smartest minds on this planet, at least until we find that ultimate answer. We are all just curious explorers in this grand space-time illusion. Why do planets float in space without falling down? For us humans, Earth is a beautiful blue planet, the home on which we depend for survival. Its mass is as high as 60 trillion tons. This number sounds astounding, but have you ever wondered? Earth, as a planet in the solar system, has such a huge mass. Why can it float in space without falling down? The main reasons are the combined result of universal gravitation, the cosmic vacuum environment, and Earth's motion. If the current balance of the solar system were broken, could Earth become a rogue celestial body in the vast, boundless universe? All celestial bodies operate in an orderly manner. The primary reason for this is universal gravitation. Gravity is a universally present force in the universe that causes objects to attract each other. Earth is affected by the sun's gravity, while Earth also exerts gravity on the sun. This mutual gravitational interaction keeps Earth in a relatively stable orbit, preventing it from falling into the sun or other celestial bodies. For Earth, the direction of its motion towards the sun is its falling direction in the solar system. The 8 planets are all influenced by the sun's gravity. following the Sun as it orbits the center of the Milky Way at a speed of 220 kilometers per second. From a certain perspective, the motion paths of the planets orbiting the Sun in the solar system appear as a spiral shape. But the Sun's gravity is so immense, why doesn't Earth fall directly onto the Sun's surface? This is closely related to Earth's state of motion. Earth's motion mainly includes two forms, rotation and revolution. We all know rotation. It refers to Earth spinning from west to east around its axis. The rotational speed is 465 meters per second. One full rotation takes about 23 hours, 56 minutes, and 4 seconds, which we call a day. Besides rotation, Earth also orbits the Sun at a speed of 29.78 kilometers per second. One full orbit takes about 365.25 days, which we call a year. This motion of Earth produces so-called centrifugal force. The centrifugal force generated by rotation can partially offset Earth's own gravity. The centrifugal force and gravity balance each other, enabling Earth to maintain a stable orbit. Earth's rotation and revolution are the most basic forms of motion in the solar system and have important effects on the life environment on Earth. This is the role of universal gravitation. In fact, it's not just Earth. All celestial bodies observed by humans can operate stably and orderly because of the existence of universal gravitation. Secondly, cosmic space is currently the closest to a perfect vacuum environment, and the universe is expanding faster than light. Earth's motion is almost unaffected by spatial resistance. This factor can be ignored. Saying Earth floats in the universe isn't entirely accurate. All matter in the universe floats in space. Strictly speaking, there is no up, down, left, or right in the universe. There is only a state of motion. Without a fixed reference object, there is no so-called falling. Falling is just a term used by humans on Earth for gravitational pull towards the center. In terms of time, Earth has been orbiting the Sun for 4.6 billion years. For a long time to come, Earth will maintain its current state of motion unless an external force interferes with Earth's current motion, breaking the existing gravitational balance of the solar system, such as a rogue star entering the solar system. Otherwise, the Sun will lead Earth, the other 7 planets, moons, and other celestial bodies to continue orbiting the center of the Milky Way. Of course, there's another possibility, the Sun entering the red giant stage. Only then would its gravity become unstable. But this scenario of the Sun expanding into a red giant likely won't happen for at least another 5 billion years. The above points help us understand that Earth can float in space without falling as a result of the combined action of universal gravitation, centrifugal force, and the cosmic vacuum environment. This balance allows Earth to operate stably in space, providing a suitable living environment for life. Besides our Earth, the Sun, which is 330,000 times more massive than Earth, is the same. It and the supermassive black hole at the center of the Milky Way are like Earth and the Sun. It is precisely because of the mutual attraction between celestial bodies in the universe that makes all this meaningful. Of course, this is just a simple explanation for why Earth can float in space. In reality, whether Earth is truly falling downwards Humans have no way of knowing because the mysteries of the universe are far more complex than we imagine. Currently, the time humans have truly spent exploring the universe is only a few decades. Human understanding of the universe is still very limited. The wonder and beauty of the universe are astounding. In the observable universe, it's not just our Earth floating in space. All observable planets are suspended in space. This is not only a scientific miracle, but also a miracle of our life. What we must do is take good care of this beautiful planet and jointly protect humanity's only home in the universe. Do you know how empty the universe is? What does the universe observed by humans so far actually look like whenever night falls and we look up at the starry sky? We see countless twinkling stars. In most people's imagination, the universe must be crammed with countless stars, but in fact, there are also many void regions in the universe. In some void regions, there are only a few galaxies distributed, and in some other void regions, there is almost nothing today. We are going to learn about a supervoid located 700 million light-years from Earth. This void is despairingly large. This content might refresh your understanding of the universe. You might even doubt whether life has any meaning. The solar system, where Earth is located, has a diameter of about 2 light-years. All the celestial bodies, large and small within it, revolve around the sun. However, the nearest star to the sun is a red dwarf named Proxima Centauri. The distance between it and the sun is about 4.2 light-years. If we were to travel to Proxima Centauri at the speed of the Voyager 1 probe, 17 kilometers per second, it would take roughly 73,500 years. According to data from radio telescopes, there are hundreds of billions of stars in the Milky Way galaxy. The average distance between stars is about 5 light-years, which is 47 trillion kilometers for galaxies. Stars are the basic units composing them, but for the vast, boundless universe, galaxies are the basic units constituting the universe. The nearest large galaxy to the Milky Way is the Andromeda Galaxy, 2.5 million light-years away. Between the Milky Way and the Andromeda Galaxy, aside from a few rogue celestial bodies, it's almost completely empty. These two large galaxies are both members of the local group, and the local group is a vast region spanning 10 million light-years, containing about 50 galaxies. Each galaxy is composed of tens of billions, even hundreds of billions of stars. Early astronomers believed the distribution of galaxies in the universe might be roughly uniform, but the appearance of a giant void shattered humanity's understanding of the universe. In 1981, astronomer Robert Kirshner, while observing the sky with a telescope, discovered, in the direction of the Boat's constellation, 700 million light-years away, a very empty region with a diameter exceeding 250 million light-years. Matter within it is very sparse, with only about 60 galaxies, almost empty. This discovery shocked the entire astronomy community and also made people further realize that the emptiness of the universe far exceeds our imagination. From a physics perspective, the space of the universe should have galaxies and stars uniformly distributed throughout. Then, why does such a special zone exist? Scientists believe the formation of the Boat's void might be related to dark matter and dark energy in the universe. The ordinary matter we see and interact with daily only accounts for about 5% of the universe's total mass, whereas dark matter and dark energy in the universe make up 95% of the total mass. They form the cosmic web structure and play an important role in the formation of galaxies and galaxy clusters. Therefore, astronomers believe the existence of this dark matter and dark energy has a significant impact on the formation and evolution of cosmic voids, also providing an explanation for the existence of the boat's void. They might shape the morphology and characteristics of cosmic voids by influencing matter distribution and interfering with gravitational fields, among other ways. The existence of the boat's void indicates that the structure of the universe might be far more complex than we imagined. Consider that the region covered by the local group is only 10 million light-years across, yet it contains 50 galaxies. The Virgo supercluster, which spans 110 million light-years in diameter, contains 20 galaxies, yet the boat's void has a diameter of a staggering 150 million light-years, but the number of galaxies is a mere 60, and these galaxies are separated from each other by over 10 million light-years. Could it be that the boat's void is a place of exile in the universe, like the exile system during the Qing dynasty? Although the exile routes in the Qing dynasty were long, one could reach the destination by walking for a few months. But if exile to a galaxy within the boat's void, escaping this region would be nearly impossible. The diameter of the boat's void is about 250 million light-years. If you were at its center and flew at the speed of light, 300,000 kilometers per second, in any direction, it would take at least 125 million years to fly out of this giant void if traveling at Voyager 1's speed. Even if you flew until the end of time, you probably still couldn't escape this region. The vastness of the universe, the distribution structure of galaxies, and the existence of cosmic voids once again refresh humanity's understanding of the universe and leave us in awe of this amazing universe. For us humans, whether it's Earth, the Sun, or even the entire Milky Way, in the face of the vast, boundless universe, they are as insignificant as a speck of dust. When we view this life from the height of the universe, everything we pursue holds no meaning. At a distance of 22 light-years from Earth, scientists have discovered a planet highly similar to Earth, habitable. Its diameter is 1.8 times that of Earth. Its mass is 3.8 times that of Earth, and its average surface temperature is about 5 degrees Celsius. It is a relatively warm exoplanet. Astronomers have named it Gliese 667 cc. This planet, only about 22 light-years away from us, makes astronomers particularly excited because this distance is just a stone's throw in cosmic terms. So, does this exoplanet have liquid water? Why has it been listed by scientists as a candidate planet for future human migration since the Kepler Space Telescope began officially operation? Humans have discovered over 5,300 exoplanets. Most of them are gas giants like Saturn and Jupiter, with a smaller portion being rocky planets like Earth, Venus, and Mars. Among these rocky planets, 24 highly Earth-like planets have been listed as candidate planets for future human migration, including Gliese 667cc. It orbits a parent star named Gliese 667c. This star is located in the constellation Scorpius and is part of a triple star system. The largest star is Gliese 667a, a K-type main sequence star, and the largest of the three stars. Its diameter 76% of the Sun's, and its mass is 73% of the Sun's. Its companion star, Gliese 667b, is also a K-type star with a mass about 69% of the Sun's. They are only 12.5 astronomical units apart from each other. The smallest in this system is Gliese 667c, an M-type red dwarf with a mass only 1/3 of the Sun's and a surface temperature of about 3,500 degrees Celsius. Although Gliese 667c is the smallest of the three stars, it has an incredible planetary system. Initially, astronomers thought only 3 planets orbited Gliese 667c, but after years of observational data, it appears there might be 6 planets near this star, with 3 located in the habitable zone. This is very similar to our solar system. In our solar system, there are also 3 planets within the habitable zone. To better observe Gliese 667cc, this exoplanet, scientists mobilized several large telescopes aimed at it. Observational data shows that Gliese 667cc has a similarity index to Earth as high as 85%. Its diameter is about 1.8 times that of Earth. Its mass is 3.8 times that of Earth, and it may possess an atmosphere and liquid water. The average surface temperature is around 5 degrees Celsius. Its orbital period is 28.2 days. It is a veritable super-Earth. If this is true, then this planet, only 22 light-years away from us, might harbor life, because we have already seen that many life forms on Earth have extraordinary adaptability, whether in the deep sea deserts or Antarctica, due to its distance from the parent star being about 11.7 million kilometers. This exoplanet might be tidally locked to its parent star. This would result in one side experiencing perpetual day and the other side perpetual night. Its day-night temperature difference might be significant. Furthermore, here one could see 3 suns in the sky. Therefore, living on this planet would be a completely different experience. The observational data for the other 2 planets in the habitable zone are also promising. Their size ratios are similar. Gliese 667cd's diameter is 1.45 times that of Earth, and its mass is 2.7 times that of Earth. Gliese 667cf's diameter is also 1.45 times that of Earth, and its mass is also 2.7 times that of Earth. As they are a bit farther from the parent star, scientists estimate the surface temperatures of these 2 exoplanets might be relatively low. Discovering 3 planets significantly larger than Earth in one star system is very rare. The planet closest to the parent star is Gliese 667cb. This planet's surface temperature is as high as 200 degrees Celsius. It is also the most massive among the rocky planets in this system. With a mass 5.5 times that of Earth, it orbits its parent star in just 7 days. Therefore, this planet cannot support life. The planet farthest from the star is Gliese 667 CG. It is a very cold world, located at the outermost part of this star system. Its surface is likely covered in ice, much like Pluto. Later, astronomers discovered another planet in this star system. This planet is located between Gliese 667 CB and Gliese 667 CC. This planet was named Gliese 667 CH. It is a relatively small planet with a mass 1.1 times that of Earth. Due to its proximity to the parent star, astronomers speculate the surface temperature of this planet might be relatively high, not conducive to the emergence of life. There is another planet, Gliese 667 CD. The position of this planet is still uncertain. Astronomers believe it lies between planets F and G, but there is no conclusive observational data yet. From the Gliese 667c star system, we can see that systems similar to our solar system might be very common in the universe. Although this star is an M-type red dwarf, observational data shows red dwarfs count for about 70% of all stars in the universe. Therefore, the number of planets around red dwarfs might be much higher than we imagine. Although Gliese 667 CC is only 22 light-years from Earth, for humans to travel to this planet is almost like a fantasy. Currently, the Voyager 1 probe launched by humans travels at only 17 kilometers per second. At this speed, trying to reach Gliese 667 CC would take at least 385,000 years. For current human technology, this might be forever impossible. Although Earth has a long lifespan, the non-renewable resources on Earth are very limited. The pace of human space exploration will only accelerate. It is believed that in the near future, humans can break the distance barrier and go to Gliese 667 CC to investigate, allowing human civilization to continue on other planets, taking root and sprouting in the vast, boundless space of the universe. What you see before your eyes is the mysterious and awe-inspiring pillars of creation, a place specifically dedicated to nurturing stars. It is located about 6,500 light-years from Earth. In 1745, astronomer Messier discovered its existence within the Eagle Nebula. Its Messier designation is M16. However, astronomical observation equipment at that time was not as advanced as it is now, and scientists didn't know that new stars were being born inside the pillars of creation. It wasn't until April 1st, 1995, that the Hubble Space Telescope pointed its lens towards the Eagle Nebula and captured this majestic and spectacular cosmic image. From the image, we can clearly see 3 cloud pillars composed of gas and dust, like cosmic giants standing between heaven and earth. The pillar on the left is about 5 light-years tall and about 1 light-year in diameter. Together with the other 2 pillars, they form a beautiful picture. This photo was rated as one of the top 10 best cosmic images ever captured by the Hubble Space Telescope. Its grandeur far surpasses that of the Horsehead Nebula 1,300 light-years away. However, the Hubble telescope's penetrating power is relatively weak. It cannot penetrate the thick dust clouds. Therefore, it couldn't directly observe the stars inside the pillars of creation. To further understand the pillars of creation, on October 19, 2022, astronomers aimed the James Webb Space Telescope, equipped with near-infrared and mid-infrared instruments, and hailed as the most powerful and penetrating space telescope ever, at the pillars of creation, capturing this majestic and spectacular ultra-clear image. This photo became one of the first representative works of Webb's deep space observations because this nebula contains abundant hydrogen, oxygen, and sulfur atoms. The interiors of the three cloud pillars are constantly giving birth to new stars, numbering over 8,000. They are all like early proto-suns, slowly forming within the nebula into shining new stars. Hence the name Pillars of Creation. We can see from this breathtaking photo that inside the cloud pillars, those newly born stars emit red, white, and yellow lights. Every tiny bright spot is an infant star being born. They will become brilliant stars illuminating the universe. This photo allows an even clearer view at the base of the pillars of creation. There is a short, thick cloud pillar, shrouded in a mysterious red halo. Infant stars inside are ready to burst forth from the top of the cloud pillar like sparks of life, about to join other stars in lighting up the cosmic night sky. Around the pillars of creation, tens of thousands of stars twinkle like diamonds. Their light interweaves, forming a magnificent star chart. This photo not only showcases the vastness and mystery of the universe, but also makes one feel the miracle of life and the splendor of the cosmos. It is not just a high-definition cosmic image. It is a poem praising life and the universe, leaving one in awe and filling the heart with reverence and yearning for this starry sky. It is regrettable, however, that astronomical observations suggest the pillars of creation might already be gone because the universe is filled with extremely terrifying forces. That is, supernova explosions. Scientists speculate the pillars of creation might have been destroyed 6,000 years ago by a shockwave from a supernova explosion because the pillars of creation are 6,500 light-years from Earth. The photo we see now is how they looked 6,500 years ago. In reality, the pillars of creation might have completely collapsed. The destruction of the pillars of creation makes us deeply realize that in the long river of the universe, both birth and demise are a cyclical process that never ceases. The pillars of creation let us witness the appearance of stellar birth and also filled us with infinite yearning for the universe. It is believed that one day in the future, humans will surely uncover more mysteries of the universe. How did water on Earth come to be? The surface of the Earth we live on now is 71% covered by water, while land area only accounts for 29% of Earth's total area. Therefore, many people are very puzzled. Where did Earth's abundant water resources come from? Did they come from within Earth or from outer space? As early as 2018, a report published in the journal Science proposed that Earth's water might have appeared before Earth itself, even earlier than the solar system. This is hard for many to understand. Could it be that water existed before Earth today? Let's understand from a scientific perspective how water on Earth formed in our solar system where Earth resides. Earth isn't the only planet rich in water resources, although Earth's water volume reaches 1.38 billion cubic kilometers. In a comparison of water content among major solar system bodies, Earth might rank outside the top 5, ranking first as Ganymede. The water volume in its subsurface ocean might be over 30 times that of Earth's water. Currently, scientists have the following 3 viewpoints regarding the origin of Earth's water. The first theory, Earth's water came from within Earth itself. The early Earth wasn't as large as it is now. Earth also formed from the coalescence of dust and gas in the primordial nebula. These primordial materials contained water molecules. Therefore, some water already existed in the universe before Earth formed. In the early stages of the solar system's formation, there were many celestial bodies covered in thick ice layers similar to Pluto, Triton, and Europa. These bodies collided with Earth, causing Earth's internal rock layers to also contain large amounts of water and minerals. Influenced by the sun's gravity and over time, under high temperature and pressure, the water and minerals within Earth began to decompose and release water molecules into the crust and atmosphere. Consider that during Earth's 4.6 billion years of evolution, the tectonic plates have been constantly moving. Factors like the heating of groundwater and gas release ultimately led to frequent volcanic eruptions. The water vapor released by volcanic eruptions cooled and condensed, forming water, which gradually accumulated into large bodies of water. Crustal movements and volcanic activities, surface rainfall, and river inflow converge to form oceans. This process also continued in a constant cycle, and the ocean area continuously expanded. This was also the initial ocean-forming activity after Earth's formation. In September 2020, a paper jointly published by Chinese and British scientists in the journal Science Advances pointed out that about 233 million years ago, Earth experienced a rainfall event that lasted for 2 million years, causing Earth's sea levels to rise. This is the famous Carnian pluvial event, which ultimately formed the oceans we see today. The second theory, impacts from meteorites and comets. Scientists' research has found that a large number of water molecules exist in the universe. These water molecules coalesce in areas far from stars and adhere to some celestial bodies, including meteorites and comets. Comets are known as mobile water reservoirs. They are mainly composed of ice, ammonia, methane, and carbon dioxide. Among other substances, scientific observations show that there are about trillions of comets in our solar system. They come in various shapes and sizes. The largest comets have diameters exceeding 100 kilometers. In the early solar system, comets had no fixed orbits. They flew around randomly. A large number of comets impacted Earth. Water-rich comets, over the past billions of years, brought vast amounts of liquid water to Earth. Furthermore, scientists have compared the isotopic composition of water from comets and Earth and found their isotopic compositions to be very similar. This further supports the feasibility of the comet theory. Because comets are very special celestial bodies, they might have an important connection to the origin of life on Earth. Spectral analysis indicates that comets are rich in organic molecules. In 1990, NASA studied organic dust in layers near the Cretaceous-Paleogene boundary and found that one or several comets skimmed past Earth and impacted here, leaving behind amino acids that formed this organic dust. NASA stated that during Earth's early formation, comets could also shower organic material onto Earth in this manner, like a light rain. This might be the source of life on Earth. One could say that for an Earth without life, being hit by numerous comets might also have been a stroke of luck, because comets played a crucial role in the emergence of early life on Earth. The third theory suggests that the source of Earth's water is not singular. It was caused by a combination of water existing within Earth during its formation and impacts from water-rich asteroids and comets from outer space. Earth contained a significant amount of water during its formation process, and comet impacts made Earth's water resources even more abundant. It was the combination of both that created the Earth we have today. If this is true, then which source of water played the most important role in the formation of the earliest life on Earth? Actually, there is still considerable controversy surrounding these three hypotheses, but the comet impact theory is one of the most widely accepted theories currently. It is believed that in the near future, the origin of Earth's early water will certainly be determined, as this will help improve humanity's understanding of the universe. Water is the source of life and an indispensable part of the human body. Where did Earth's water ultimately come from? With the continuous advancement of technology, this age-old mystery is bound to be solved. All right, my friend, let's pause our conversation here tonight on the mysteries of the universe. Now, allow me to press pause for you. Set aside all thoughts and inquiries and simply, quietly be in this moment. From here, my voice will fade away, leaving only the silent tapestry of the cosmos and a carefully chosen piece of pure music tuned to 432 Hz. Science suggests this frequency resonates deeply with the natural vibrations of the universe and the rhythm of life itself, soothing your nervous system and guiding you into deep relaxation. Now, find your most comfortable position. Gently close your eyes or let your gaze rest softly upon the stars. May you release all weariness from the world, letting your consciousness drift on the waves of music, floating into boundless tranquility. Good night, sweet dreams, until we meet again among the stars.